Cool. I think a decent amount of people are here. It would be great if people turn their cameras on. It's so nice to see people. It makes for a more social atmosphere. Please feel free to drop your socials and connect to each other in the chat. So before I take up too much time, I know Neal's got a lot planned. I will hand you over to Neal for the Building on Urbit workshop.
So we covered a lot last week, right? We explored what Urbit architecturally looks like as a platform and how these different components fit together. You know, there's an Urbit OS, there's an Urbit ID. You know, what do these parts mean? What do they offer you as a developer? How might you start thinking about making a decision of which part of the system you want to use or employ in your hackathon solution? That's a big order to deal with there. Today, I think we have a lot more, because as you drill down deeper, of course, there's a lot more to say about particulars. So as I look at app development, there are a lot of different paths I could take in explaining this to you. App development on Hoon, or using Hoon, which is the Urbit programming language, requires you to get used to thinking about code being structured as expressions in a very particular way. Many programming languages give you a lot of freedom in how you structure the kinds of code expressions that you're making. I'm thinking about things like Python and JavaScript here. These are imperative languages, and so you tend to just be telling the computer what to do each step one after another. You know, C kind of falls in the same vein. And there's a certain flavor to programming on those platforms. Hoon is going to feel more like working with a Lisp. Some of you may have worked with a Lisp like Scheme before, or even something like APL, which most of you have probably not worked with, but is an interesting programming language here. So what I'm going to be talking about first is how do you set up your developership, your developer instance, so you can actually work on Urbit. Then we're going to be taking a quick look at what the Hoon language looks like. My intent there isn't to teach you all of Hoon. I can't do that in the amount of time that we have in this workshop. I'd like to teach you enough Hoon that when I show you Hoon later on, when we start looking at app development, you won't be lost structurally with what is taking place. Then we're going to look at the user space app framework and how that works and how we think about putting apps together on Urbit. And then at the end, I'll get into front-end apps and what it looks like to talk to the ship via HTTP and JSON and so forth, and explore some of those kinds of ideas. I expect this workshop to be pseudo hands-on as a workshop. You're probably not going to be able to follow along with it as we're going through it now, but it may be worth coming back to it later on, or to some of the resources that I'm going to mention, and work through those hands-on as well. Because we're probably going to move too fast to keep up on typing or to troubleshoot things as they may come up. Okay, so you should see my Urbit. Well, you should just see a command line here. There's nothing Urbit-y about this command line yet. I have a window here with a regular bash command prompt at the top, and down at the bottom I have another one, so I'm able to switch back and forth in case I need to take notes while I am working here. Now, when you've looked at Urbit ID and working with Urbit in light of last week, you may have gone and downloaded Port, for instance, and run a commit, or you have a planet, or you have some way of working with an Urbit ship. We are going to use developer ships, fake ships, rather than live network ships to carry out software development. This is a little bit, so it's a little bit nicer because it means that you're not going to be receiving updates and things while you're working on your program. You know, a ship that's live on the network is talking to other ships on the network. If there are software changes upstream that may affect something you have downstream, those changes will get pushed through. So you don't really want to develop in that kind of an environment. So we are going to start off with, how do we run a fake ship? Port will not let you run a fake ship. It's only for live network ships. And so you'll need to go to, actually, let me share that screen. Okay. So if you go to urbit.org, at the top, you'll notice there's a get started. And if Zoom will decide that I can click behind it, I will click that. There we go. All right. So you'll come here and it has some different various options for you to take a look at as you're trying to figure out what's going on here. It suggests hosted Urbit and command line Urbit, and then the desktop app is kind of the three ways of interacting with it. Most of you have probably played with the desktop app or maybe hosting or so forth. Command line app is what we need to actually run things. It's easiest to do this on a Linux-like system or Mac OS. If you're working on Windows, I recommend using Windows Subsystem for Linux or getting a DigitalOcean or AWS cloud instance to run things on. It just will run a little bit more smoothly if it's in a POSIX environment. You will locate the particular program that you need for the architecture that you're running. So if you're running on a regular desktop Linux, if you're running Linux on a Raspberry Pi ARM architecture, then you'll choose whatever that is. You'll download the program using this command line. You'll probably skip this aside that it has here, and then you'll get a message that says Urbit. Here's Urbit. I have already done that for this particular case, so I won't be recapitulating that. In my ship, on my computer, I've located everything in a folder called bin. So I run /bin/urbit to execute this, and it gives me a long output of a lot of information, what my command line options are, and so forth. Now, go ahead and clear the fake ship that I had there. To create a fake ship, we still have to pick the name of a ship that's a valid identity within Urbit. Conventionally, we use Zod, which is 0.0, which is the root node for the entire network. -F lets me specify that this is a fake ship. This means that it will not check azimuth public key infrastructure, and it will not be able to communicate on the network. It doesn't know about the network. So it actually knows about the network in the sense that if you have multiple of these running on the same local host, if you're running them all on the same machine, they can talk to each other. So you're able to test networking and so forth when you're working locally, but it will ignore the network, the real network in those cases. And it will go ahead and you'll probably get 1.13 if you download. There was a recent update that had some changes. I haven't bothered to update on this particular instance. And it will run through this boot sequence here. It'll tell you that it's downloading what's called a pill. A pill is a bootstrap sequence. It's a set of instructions that are necessary for this ship to come to exist. And then it will run through, it's like watching a DOS machine in the 90s. It runs through all these arcane instructions that are telling you what's going on if you know how to read what's going on here. If you don't, it's fine. You just wait until you get to a regular prompt. So we are going to have to wait a moment for it to reach that point. Commentary on some of this. So it's installing what are called desks. Desks are the unit by which we distribute apps, for instance. So there's a Bitcoin wallet app. Landscape is the main social media interface. There's a web terminal that you're able to use. Base and Garden are both shared libraries that are used by various parts of the system. And then these are particular apps that are running on the system that are installed by different parts of what's going on here. The parts that have front ends that are going to be interacted with through your browser, it goes and it fetches those packets of HTML and JavaScript and whatever else it needs to be able to build those, and it keeps running down this whole list here. Urbit applications are distributed on what are called desks on the file system. These are similar to branches in Git, so you can think of every application as being a different Git branch. Not a perfect analogy, but it kind of gives you the idea that you're creating a new collection of files and resources that you're able to share distinctly the way that you could if you were working on GitHub. So this will be the way that we will distribute software when it comes time to circle back around to that point. Now, once this is all done. It's going to run down alphabetically, so I know that I'm at I, L, M. So I'm about halfway through starting up all of the apps on this ship. Then we will get to a prompt, which is a regular. We took a look briefly at it last time. This is a command prompt. If we're running bash, then we expect to be able to run bash commands and use it to execute programs. This is a command prompt, kind of like in Python or MATLAB, for instance, where you're able to type commands that are system commands. You're able to run things that are locally in your directory, and you're also able to evaluate code. So you would be doing all of those things here. So we're to the prompt here, and it will just sit here and wait now that it has this information available. So we now have a fake ship, which is running on the NOC virtual machine, and we're able to write hoon code inside of this. Hoon is a language that has a lot of irregular syntax that has been introduced. You can use the regular syntax or the irregular syntax. Many programmers will use the irregular syntax exclusively because it's faster, syntactic sugar. A lot of programming languages have something like this. This is like using C or C++ preprocessor macros, for instance, where it makes it more expressive, perhaps easier to read for the programmer looking at this. And it does map down to fundamental language constructs, but it's not strictly formally part of the language in the primitive sense. I don't want to get too distracted by that, but when we look at Hoon as a language, we are not always going to be able to see the regular nature of its structure. Sometimes we will, sometimes we won't, but it's all regular if you dig down under the sugar syntax that's in place in some places. Now, everything in Hoon is either a bare value or a pair of values. So we can imagine that if we're thinking about what's on a computer, if we're looking at memory, like what's being pulled in, what's actually being run by a CPU. A CPU is basically where three kinds of information. It can pull something in, pulls in a byte of information. It has to decide what that is and what to do with it. It can decide that it's a command, which it does based on its position, right? Like the first part of a machine language instruction is the instruction. It tells it what to do. It tells it to move memory or add memory or whatever. So it can decide that it's a command. It can decide that it is a value, right? It can interpret that binary number as a number, which would mean an unsigned integer, and then maybe it can treat it as a letter or treat it as if it were a floating point number, so forth. But at the most fundamental level, it's just pushing around zeros and ones that are a binary value. So it has a command, it has a value, or it can be a memory address, right? It can be a pointer to somewhere in memory, and it's telling it what to do with that pointer in memory. Hoon doesn't carve things up quite the same way, but everything in Hoon is either a bare value, so what I'm going to call an atom, right? It's this irreducible value. It's a number. It's an unsigned decimal number, but it is a number, or it is a pair of things, right? So I'm going to call these nouns. So a noun is either an atom or it's a pair of nouns. So we're able to build binary trees of information from elaborating on this kind of structure. It means that ultimately everything in Hoon, every value that you're expressing, every program that you're expressing is a binary tree. There's a lot of nice formal things that fall out of this, and a lot of interesting guarantees and structural assumptions you can make because that is true. For you as a programmer coming in and writing code at the hackathon level, where you're kind of learning a quick and dirty version of the language and then building things on top of it, it's not critical that you sort of deeply dig into that like at a CS2 kind of level. But my type of number, like 123, of course, this has some sort of decimal, this is a decimal number. It has some sort of binary representation, and I can interact and work with this value here. And I can also have
Isaac, you're muted.
Pairs of numbers. Isaac is muted. I don't know if he's talking to us though. Okay. So we can also have pairs of numbers here. And so if we need anything we put between square brackets means that we have a pair of numbers. And then we can build things that are pairs of numbers. And one of the irregularities of Hoon is that if your pairs always branch to the right, it means that it stops including the square brackets around the right, most things. Okay. Now, when we evaluate a statement, what we're going to be doing is we're going to be taking a name of some command that's in our scope, and we're associating values with it. So we're writing it in an irregular way that looks like Lisp. So if you've worked with a Lisp language before, parenthesis, function name, and then whatever parameters are passed to that. The other way that we can write this is we can pass in the values separately. And so we have this %- rune, and it's telling me that I can load a name add. It has two children. It first is the name of the thing that it's loading, and then the second are the arguments that go. Loads a name, and then it loads the arguments that go to that. It's a very formal way of thinking about it. If you've worked with like a combinator calculus or a lambda calculus or something, you've seen that there's a lot of, in fundamental CS, there's a lot of very formal ways of thinking about looking up names, assessing values, and putting these together. So this is essentially what we're doing. And so these two statements here, add 1, 2, and then % - add 1, 2. These are syntactically equivalent in Hoon. And so we'll see a lot of these different structures as we build these together. Now, this also means that we are going to be building more complex structures that have the assumptions of things being binary trees. The most important of these, all right, here we go. The most important of these, all right, so let's say, so a noun is an atom or a cell. And then the next thing we're going to take a look at is what we're going to call a core. A core, so if we're saying we have a program on a computer, presumably we're saying we have some set of instructions, and then we have data values that associate with those instructions. All right, so we have code and we have data. So a core ultimately is a cell. So it's a pair of information, it's a pair of these things of all of the code that corresponds to your program, and then all of the data that is going to be evaluated by this. So even something simple like add, if we go back up here, okay, I can only select when I'm up here. There we go. Even something like add it's basically saying, I have a set of code and I have an empty slot that's waiting for data. And then the data that it receives is, of course, the values that we actually want this to operate on. So, we run into this, right? So if we're in a language like Python, we might say, define add, and we'd tell it, there's an X and a Y, and we'd say, return X plus Y, and we'd create some kind of statement like this. And so the code would be whatever lives inside of that expression, right? The name add now exists for Python, and you're able to talk about add. The interpreter knows that add is a function that it can use. But until you actually provide it the arguments X and Y, you can't do anything with it, right? It's inert. And so a core is going to be our fundamental way of organizing these kinds of operations in Hoon. Now, let's see, let me write. So I'm going to be working in my dojo. I will give you this code as soon as I have typed it in because I am making it up right now. So I'm going to name this test. And I'm going to mark it as a core. So that's what the bar % at the top of this is going to do. It's going to mark it as a core. So we're saying we're going to have code. I'm providing the code, and then we're going to be able to provide data to these as we work with them. So I'll name one of these components in here add to, and it is going to accept a single value X, and it is going to return X with 2 added to it. All right. Let me give you this code down here in the chat. All right, this program that we're looking at here, I have given the name of something. I've named this this particular instance test, and I've created a function inside of this core that is called add to. You will notice, looking at this, that there are parts of this program that are single spaced and parts of this program that are double spaced relative to each other. One of the interesting quirks about Hoon is that it distinguishes different kinds of white space from each other. This isn't unprecedented. Python does it, for instance, right? Different kinds of spaces, different kinds of indentation are meaningfully different in Python. In Hoon, if we're going to separate the children of keywords, the children of runes, which are these paired values here, paired ASCII characters, like this ~, or this ++ here, those must be separated by either two spaces or a line break. And so a line break and two spaces are the same thing. Other values, like arguments to a particular function, can be separated by single spaces. You'll get used to that as you look at the programming language, but it is something it means that here, this top level core expression, this ~, has one child, which is everything else in the program. This ++ has two children. One of the children is the name that's attached to it, which is add to. The other is this function definition that sits beneath it. This function definition is saying that it takes an argument. It has two children. This bar equals has two children. One of them is the arguments, the function signature, if you like, and then the actual code that is associated with it. All right, so this is what we're drilling down as we do this. And to use this now, as we would say, add to and resolve that within the name test, which is what we assign to the whole thing, and then pass in the data that get associated with that particular value. So every name that you give a program in Hoon is resolved against some scope. The implicit scope, the outermost scope, is when I just say things like add. But for most of the time, you will be resolving things that aren't in the standard library in a particular scope. So here, for instance, I created a particular scope named test, and then I created this collection of core, it was core, so it's a collection of code and data. So it's the code that's going to be evaluated when the data are provided there. A different program could look like this. Let me give you test 2. If you arrow key back up, you can come through these again. I will also give you the whole thing in a moment. And I can define more than one name inside of this. There's nothing special about X. Let's see. Oops, that's not going to work. If you make something that's not going to work, you start typing it, you press backspace, and it changes back to the right hand greater than symbol, then the right hand arrow. Then it will clear what you were typing. You're able to start over again. And what I did wrong was because I was arrow keying back up, I grabbed the wrong thing. All right, so I want to add x2. I'm going to add a new function here. Y equals pat and sub y2. Right, and then the double dash indicates that I've reached the end of that there. So let me give you this code as well. Right. Yeah, if you go to the right-hand side of the meeting chat, there should be 3 dots that will allow you to, maybe you have to mouse over it. There should be a way for you to select it with the spacing correct. Anyway, we'll come back to that. All right. Now, in this case, if I want to subtract 2, within this context, and I can give it a value like this, test 2, right? So if I give it the wrong context, it tells me the hoon expression failed because there is no value, there is no function named sub2 inside of test. Test is the one I created earlier. There is an add to and do this. Yeah, and Sarlov Sarson in the chat points out that if you don't select copy from Zoom, then Zoom turns all double spaces into single spaces, and you lose the syntactic information that double spaces are distinguishing here for you. Now, if you're going to learn how to work with Hoon, we have a set of guides called Hoon School at developers.urbit.org, which are the thing you should delve into and take a look at to learn the details of the language syntax. That is, if we go back here, developers.urbit.org. So you would go here, scroll down a little bit on the page, and there should be a Hoon School guide. All right. This is, some of these are optional. There's 19 lessons here. Some of them are optional. They are marked as optional at the top of the page, which just means that if you're trying to get up to speed quickly, it's something like, it's floating point mathematics, for instance. You don't need to know floating point mathematics to get a program working. You only need it if you're going to do, numerical mathematics and you care about that. So we indicate those things, and we kind of give you a feel for how Hoon behaves as a language. When we're going to read Hoon programs, what you're going to be looking for is the structure of, you're looking for the pairs of values here, and what these are telling you about the ways that these different components relate to each other. All right, so think of these as relational statements. They talk about what is being defined the same way a keyword would in a program like JavaScript. Excuse me, in a language like JavaScript. But they are also, they're laying out this backbone of the program, like the way that the logic in the program flows. So we are going to look now at how to build apps in Hoon, having had this hyper minimal look at what does the language look like. Apps and most programs are going to be a mix of ASCII characters, which are these punctuation like mark runes that are keyword like operations, and then names for things that are English or English like or not English like, depending on the taste of the person who actually wrote the program. But the mix of it will give you a feel, sort of like having labeled blocks. Like if you were building a program out of Legos and there were words on the different Legos, your brain would be able to switch context between those things and keep track of which is which. The other thing, the next part we're going to take a look at is App School. So App School is a whole other set of pieces here that teach you how to put together programs. We are going to look at what does it look like to build an Urbit program. What does a Gall as an app framework actually look like? All right, so let me get a clear Gall instance here and scroll down to my notes. All right, let's see. With respect to Hoon, one of the things you care about as a competitive programmer as well is being able to quickly answer certain kinds of questions. So there's a competitive programming guide that I PR'd against the site, and I will see if I can get it merged today, that I wrote last week, that essentially walks you through, if you want to find prime numbers, if you want to sort a list, if you want to carry out these kinds of operations that turn up in practice, like what would those look like? That doesn't mean you necessarily want to do those operations, but you want to understand how the code works in such a way that you could modify it to do the thing that you actually want in some particular case. So binary operations, mime data operations, right? If you have hexadecimal values, if you have JPEGs, if you have whatever you're passing around, how do you actually interpret those values? So the competitive programming guide has more of that from a Hoon perspective, like what does it actually look like to receive, process, and then return values back out. All right, app program here. Okay. All right. So if I'm writing a hoon program here, this is the simplest possible hoon agent, hoon app. It doesn't do anything, it crashes if you actually try to do any interactions with it. This is kind of a say nothing hello world program. Now, what you should see when you look at this, you should see some runes. Some of these look like runes that I just showed you a moment ago. Some of these do not. Okay, so there are new runes here. So if I'm scrolling around this bar underscore that I'm starting this with, this kind of looks like the bar percent sign that I had a moment ago. It's a little different, but it's the same. It's a similar sort of idea. So it's some kind of core, but it's not the basic kind of core. Okay, and it has some sort of value associated with it called a bool that's written in, you know, whatever hoon syntax is here. And then there are 10 functions defined inside of this core. All right. Again, don't get hung up on the language right now. You have time over the next, 5 weeks to dig into that as deeply as you would like to go. Look at the names of things here. What are the kinds of things that are defined for a standard program on Urbit? Well, there's an initialization arm. So on init is whatever happens when you start this for the first time. Some programs will have state, right? When you start them for the first time, they will need to know something. Maybe they know about things like users or game scores or, wallet addresses, DApp addresses, things like that. Those have to be initialized at some point. So they would be initialized in this branch of this core. So on init is where you put any of your setup instructions when you'll put those together. On save and on load are interesting, and they're dealing with a case that happens in Urbit. You may recall from last time that I talked about Urbit hot loading code. So what happens is when you start running a program on Urbit, it's basically running forever. Okay, if you start a program on a particular Urbit ship, that program now exists. Urbit is a functional operating system. The state at any given point is immutable. And then, so if you want to make a change to the system, you have to create a new state and then add that onto the end of the system. And this represents, the evolution of the system. Urbit processes events and it maintains a state machine, the current state of the system, but it basically does this the way that a language would, again, with Python. If you're working with a list, you can change a list. A list is mutable. A tuple is not mutable. If you want to change a tuple, you have to load the tuple, create a new tuple that has the changes that you want, and then present that new tuple with the name or wherever you want it in memory. Urbit is kind of like that, but it's also like that at the program level. Every program is a state machine. Every app is a state machine. This means that if we want to update or change our app, if we want to pass an update to players of this game, if we want to change the way scores behave, for instance, we want to change the number of players that can participate at some point, anything that you might like to change in a game. This means that you're going to have to save your current state, and then on load is going to tell it how to make changes from the former state of the program to the new state. So this may tell it to remove variables that are now superseded, deprecated. It may tell it to add variables. It may tell it to change the names of some things, change the addresses, the DApp addresses to which are stored in it and to which it points. And so one of the consequences of this is that every Urbit app has a perpetual forward compatibility. Once you write it, as long as you write an update path in your on load for every subsequent version of this, then anyone should be able to come from any point in the past and update to run your current version of your software without losing their previous information, without losing previous state. There are, let's see, poke. Okay. A poke represents a one-time interaction. Okay, so a poke is I'm giving this agent, I'm asking this agent to do some operation. I may be asking it for information like, what is your current score? Or, I made a move in a chess game and I'm telling you what this move is, for instance. But it's a one-time move. So a poke is a one-time move. Urbit adopts a pub/sub methodology. If you've ever worked with a system that has a data flow architecture, it will use what's called pub/sub, publication subscription. And so what this means is that if you want to track the state of something in your system, you subscribe to some source of information. Urbit calls it a path. That's not a universal name, but basically you subscribe to a path, you subscribe to a source of information. And that source of information maintains a list of everyone it knows as a subscriber. And whenever it makes a change, it notifies every subscriber automatically about the change, about what has happened. This means that you don't have to write a web app or something that is continuously polling for information, right? You can imagine, where you've got some sort of status and you're trying to see if someone's online. Well, one way you could do it is you could ping them every 5 seconds until you know that they're online and then they're there, right? This generates a lot of network traffic, and depending on, latency and messages and so forth, you might get things out of order, and it can be a little bit messy to handle things with a bunch of serial one-off calls of this nature. A pub/sub method would say you subscribe to that ship, which means you ask it to notify you when it comes online. So every time it comes online in the future, it will send a notification to all of its subscribers that it is now online, that it is now available. And so it's a little bit more elegant of a way of handling things. And so the on watch arm means that someone, let's see if we get this right. On watch means that someone has asked to subscribe to you. On leave means that someone has asked to unsubscribe from you. So it means if you need to stop keeping track of them or send them some final state or something like that, then you deal with that in on leave. So you can either, they can watch you or they can leave you. This is your pub/sub method. On peak means that you are requesting to see information, and you don't know, you know that information is available. It is an immutable state observation. You're simply saying, what is your current value of state? What is the thing you currently know about for this particular variable, for instance? It requires you, of course, to know something about the architecture of the program, but it just means that you're requesting information. You'd like to know something. So a poke is sort of a one-time tell them something. A peek is a one-time ask to look at something. A watch is an ask to subscribe to them. A leave is telling them you're unsubscribing. Let me actually write these all over here to the right. Okay, so initializations start up. Let's see. Poke is a one-time command. Watch is a subscribe request. A leave is an unsubscribe request. A peek is a one-time data access, I guess is what I'll call that there. On agent is a subscription response from an app. It means that some other app has made a change and it's telling you that it made this change. Incidentally, all of these double exclamation points, that's the crash rune. It means, crash, like nothing happens here. So all of these are just crashing, basically. This is a subscription response from the OS. So you can ask the OS to tell you certain things. You can ask it to carry out server or client operations, to send HTTP messages, to communicate with other ships, to check on the state of the public key infrastructure, to open communications channels, to set wake up timers for different processes. All these kinds of things we can do. We can ask Arvo, which is the Urbit OS, to do this for us. And then finally, there is a this is our error handler. This means that we've failed to something has been requested here, and there's been an invalid crash somewhere else, and this comes back and it calls my on fail, and this is just my handler, right? Like, do I need to do anything because something else failed? Maybe I do, maybe I don't, right? These are kind of my default cases here, and I'm able to expose these to the world. This gives you the logic of the way that an Urbit application works. Now, in a real Urbit application, there would be a fair amount of code over many lines associated with every one of these. And we'd be able to drill down and say, okay, exactly, what is onPoke doing? How does it handle certain kinds of information? What does onAgent do? What does onArvo do? Let's jump over to one of the example codes on developers.urbit.org and see what that looks like in practice. There's Hoon School, there's App School 1 and App School 2. App School 1 is basically building a backend only. It's just the Urbit side. So it's sort of like building the database and logic end of a program, but there's not everything that you're interacting with is just done at the command line. App School 2 full stack is telling it to, how does it actually talk to a front end instance there. Both of these lessons are shorter than the Hoon School lessons, because once you know the language, you can drill down and go into these here. Let me take a look at pokes. Okay, so here's an onPoke arm, a full onPoke arm. It receives some kind of information. In this case, a mark and a vase. A vase represents your raw data, perhaps with a type, and then a mark is sort of a data type, file type handler. So we're getting that information in, and then we're returning something, which is a quip card. It's basically a list of, it's the current state with any changes and any events that need to take place. So let me label these. So this is accept type and data, so it knows how to interpret the data. And this will say is state change plus events. And let me go down a little because Hastebin is blocking me there. All right, that's those cases there. And then this is a switch statement with the default. So the default setting is to just fall back to whatever the default onPoke handler is. That part makes sense anyways. If you don't recognize the mark, then do the default action. Logically, that should make sense, even if syntactically this is a little bit new to you. And then the marks that it's looking for something that is marked as a noun, right? This is the generic type. Noun being, of course, the container for anything, right? Anything can be a noun, an atom or a cell or something more complicated than either of those is a noun. So this just means that we're not putting any type information here. It's the most general type, whatever value we receive here. A value definition, and then we're making a decision on the basis of what the action is. So this is a switch without default. I'll just call it switch without. So if the value is to increase a value, then it's going to make some changes, and if the value is to decrease a value, then it's going to make some other different set of changes. All right. We don't know exactly what all of these are. We know that these are realizing what those changes are in the way that I was talking about. Basically, these are structured events that the Urbit operating system knows how to interpret here. So most of these are boilerplate, right? Boilerplate means that they're fixed. That means that we don't have to worry about changing them. Most of the values in this are boilerplate, and so you wouldn't have to change them in many cases. But some of the values that you're passing around, you may change, for instance, if you were going to do that. Different kinds of arms. Let's look at. So a subscription could look like. Actually, this is a whole program. Let me look at this whole program because this will have some subscription logic in it. And it'll start to give you more of a feel for how these programs look when they're longer. All right. So this program comes in, look at the runes. You don't know what they mean yet. That's fine. These first two are imports, two different kinds of library imports. Bar percent we saw when I was naming things earlier. There's some type definitions that are included here going on down. And then this bar underscore is similar to what I saw a moment ago when I was showing you the minimal example of a Gall agent. So it's some kind of core. So let me. Core, so the core is our data, code and data. It's a cell of code and data. Some other definitions, and then, okay, there's an on init arm, there's an on save arm, there's an on load arm. Now, the on load arm is actually doing some kind of logic to look at what is my old state and do I need to change my state? You probably don't, because this is version 0. It means we haven't made any changes yet, but it's the handler logic is present. There's an on poke. We just looked at an on poke, but it was a little bit different than this. But you can still see the same structure here. Input, return type, and then switch over what a noun is. And this one looks like there's a subscribe and an unsubscribe rather than an increment and decrement operation that are associated with it. Some of these are default arms. They're not doing anything special. They're just persisting as they are. We're not expecting to get anything back from our operating system, and we're not going to do anything special if anything fails. So we're going to ignore both of those at the bottom. But this logic right here on agent, this describes the logic that happens when we have subscribed to something and we get a response back on that subscription. So this now is logic that is telling it, how to handle what happens with a subscription. And so drilling down into, once we've extracted the information, there's a watch ACK, there's a kick, and there's a fact. These are the three things we care about here logically. A watch ACK means that we have succeeded. Well, it means that it's acknowledged that we have attempted to subscribe, is what a watch ACK means. That can either succeed or fail. So we can either get a to-do watcher subscribe succeeded or a to-do watcher subscribe failed. We can get a kick, which means on their end, they have refused to subscribe us, and we have to, so in this case, it decides to attempt to resubscribe and see if it can do that. Maybe it can, maybe it can't, but it's going to at least once try to resubscribe if it drops the subscription, if it loses the subscription. It's kind of a code security mechanism. And then a fact means I actually got information back. And when I get information back, then I have to extract the information. It's a to-do update. And then I'm going to call it against this to-do update operation that I have somewhere else and return those values back out. Now, I prefaced it with the hoon code is a little bit dense. It's something to get used to. I'm going to postface this with the same comment, okay? When you want to write a hoon program, you are not going to sit down and write it from scratch. Certainly not at the level that you are coming into this at, and that's fine. You're going to go around, you're going to places like urbit.org/ecosystem, if I can spell that. And you're going to find programs that other people have written. There's an applications tab over here. You're going to find programs that other people have written, or you're going to ask for recommendations. You're going to see how they built what they built and how you can tweak it modify it, how they accomplish something. Do you agree with it? Do you disagree with it? You're able to do all of these things and actually go play with it, right? Like make it do what you want it to do. We'll get deeper into that on Wednesday when we talk about some app ideas as well. Okay, so don't get bogged down too much by, I don't know what this code means yet. You have some breathing room, and you have a lot of people who will be happy to help walk you through what's going on here. But the place to start if you are going to develop on Urbit is with Hoon School docs. Go through the Hoon School docs, skip the optional lessons, and then take a look at least App School 1. And once you've done that, you'll be able to run and interact with things. Now, I'd like to show you one more example here. Let me run Urbit on a moon that I have running locally. All right, so I have a moon. I've called it Sample Palnet Lagrev Nakfeb. It's the name before it in the dojo. And I would like to request information from it so that I can know what the state of some particular ship is on the network. Okay, so if I would like to know about Lagrev Nakfeb, which is my ship, okay, so I'm going to post to, let me go ahead and post to my local host because it's not that remote HTTP address there, which is also missing a colon anyway. So I think that's gonna be a problem. All right, so let me go to my ship, my moon that I had up above. My moon is running locally. So I'm going to post to v1/roller. This is the layer 2 roller. So you can actually see the status of things that are anything in the Azimuth PKI. I can find out information about it. It's a JSON RPC, so I send it the standard method, which is get point. What data type is this thing right here that I've highlighted? Right, it's a JSON structure, so this is communicating with JSON via HTTP post command. And if I run it, then I get back this information here, which of course is terribly structured. But it does tell me things like, what are the publicly known addresses for various things? So I've never assigned the transfer proxy, the voting proxy, or the spawn proxy, so those aren't visible to you. But the management proxy and the owner proxy are known, right? And it's a public key infrastructure, so the addresses where those are located are known. I have the private key somewhere. You can't see and interact with those. So I'm able to request this kind of information, and I can find out other things about this, like the number of times that the ship has been reset on the network and so forth. So these things are publicly visible. And I can use them to make decisions. So if I want to work with Urbit ID exclusively and not with Urbit OS as a program, what you'll need to do is use these roller HTTP commands. You don't have to do them through curl, of course. You can do them any way that you would normally send an HTTP request. For simplicity here, I'm showing it with curl because it just lives at the command line. But you will have to be able to talk to an Urbit ship to get that information. Front-end development is going to communicate similarly. You're going to use get input HTTP calls optionally with a cookie to validate, to actually communicate with everything that's going on if you need to talk with the ship. So you can build front-end apps that are regular, React or whatever JavaScript framework that is happy to talk to any backend via HTTP. Urbit is a backend that speaks HTTP, so from the front end's perspective, nothing is different there. Okay, a few final points, and then I'll go ahead and wrap up. Hoon is a lot of fun to develop in. It's a little bit unusual to get used to. That's okay. Urbit's platform guarantees make it easy for you to implement serious software fairly quickly. This was a whirlwind tour. This is not me saying that you are now like having seen this for the first time, you are now prepared to go forth and write hoon code. This is to give you the flavor of how everything looks and feels and what to expect when you dig into this now. Do not be shy about looking up runes or asking questions. There's a lot of sugar syntax, as I mentioned at the beginning. If you see a confusing and dense expression, check for irregular syntax, ask people. The community is super friendly about answering these kinds of questions. The standard library probably does more than you expect with parsing a bunch of operations. So there's a lot of things like, if you need to sort things, there's a built-in quick sort that you probably use in almost all cases, unless someone were asking you to write a sorting algorithm. So you don't need to worry about it, right? You can just write some kind of binary comparator, and then you're able to sort things fluently. We stand prepared to answer the questions that you inevitably will and should have as you get used to working with this programming language. Now, that said, there's full on Urbit app development. There's front-end development where you're writing a front end that talks to something on Urbit, which may mean that you don't have to write any hoon code at all. There's Urbit ID related projects, which would mean that you're just throwing JSON calls at an Urbit ship to do things. There's bridge applications, as I mentioned. There's a lot of different ways you can go with this, depending on your taste. So keep that in mind as you work on this, as you figure out your team, and as you decide what and how to proceed in implementing this. All right, Isaac, that's what I've got.
Cool. Thank you very much, Neal. So I know you've been really active on the Discord. So if anyone's got any questions, please shoot them over there in the technical channel or the club room or wherever. Yeah, as I say, thanks very much. I know you were trying to fit a lot into a short amount of time. Thank you everyone for coming. Our next talk or next workshop will be on Wednesday with Neal and Salev Sarsen. And I will share more details of that with you on the Discord and by email. So hopefully see you all next Wednesday. Thanks very much.